All right, welcome back, everybody. So for today, we're going to be reviewing for the Unit 6 test. And we're going to start it off with section 6.1. So as usual, we'll do some problems together. You try the others on your own. That's part of your classwork there. All right, so we're going to start off with 6.1 that dealt with graphing. When we're talking about graphing, of course, we have to know who the parent function is. And just remember the parent function does not include any numbers. So when I look at this one, yeah, there's g of x, so there's my y. There's the x, but look, there's no power of 2, there's no absolute value. The 2 and the 3 are separate from that. So then, of course, the parent is a linear function. And if we're dealing with the linear function, then we're talking about the equation y is equal to x. So I can create my little table as usual. Might come in handy, you never know. So my points are negative 1, 1, 0, 0, 1, 1. So here is the parent function. Quick little sketch of it. Let me get my straight edge here. All right, so here's the equation of y is equal to x, the parent. So now let's talk about what every variable does to the actual graph. Sorry, every coefficient here, every number. So we have a number 2 out in front. And when we see a 2 out in front, remember one of the things they want us to do is describe the transformation. So we will describe the transformation here. The a value is a 2. And when it's right above, so let's zoom in a little bit more. Part of the description says, part of the directions say describe the transformation. So when my a value is equal to 2, and there's no adding or subtracting there, this means this is now a vertical stretch. So for this problem, we'll write it down here. We're going to do a vertical stretch by a factor of 2. So we'll say by 2. Now remember what that means. When we say a vertical stretch by 2, it means all I have to do is go over here and multiply all of my y values by 2. This is how we actually do a stretch or a shrink. It's by multiplying our y values. So yes, I do get a new table of values here. Still a negative 1, 0, 1, but now my y values are 2, 0, and 2. So we're going to take care of the stretch now. Let's plot these points. So negative 1, negative 2, 0, 0, and 1, 2. So there it is. Again, let me bring my straight edge here. So this one here isn't our final answer, so I'm not going to make it dark yet, or solid, we'll say. But this right here is what a stretch looks like. Remember, the stretch means you're pulling it away from the x-axis. So because it was down here, it got pulled away from the x-axis again. So my stretch is y is equal to just 2x. But there was actually one more number here involved. And if you notice, there is this plus 3 in the back. And we already know that when we are adding or subtracting outside of a function, that means we're actually going to move up. So we'll put that down here in the bottom. We're going to translate up 4 spaces. Or sorry, what am I talking about? Up 3 spaces is what we're doing here. So we're going to move it up 3 spaces. Quick little fix here. So we're going up 3. All right, well then all these new points that were in kind of this blue-green line here, we're going to move them up 3. So 1, 2, 3. So that's way up here now. 1, 2, 3. And of course, 1, 2, 3 spaces up. So there's that same line that we had here with a slope of 2. But now, of course, it has been translated up 3 spaces. And so just like that, this red line here is the one that I can officially and finally call g of x. And there's our graph of the function that they wanted here. But again, it helps, right? When you do a vertical stretch and you have to multiply everybody by 2, it does help to just kind of draw that on its own afterwards. Okay, so let's do another we do. So looking at this one now, again, we need to recognize who the parent function is. So just to look for the parent function, there's my y value. There's the x, remember no other numbers, but this one is surrounded by a power of 2. So because of that, I now know that the parent function for this one, so this basically is a quadratic. So the parent function is y is equal to x squared. Well, I already know my points for that too. It's negative 1, Oh, this was a negative 1 down here on this side. Sorry, just caught it. A negative 1, 1, a 0, 0, and a 1, 1. So yeah, just be careful. This was supposed to be a negative 1 here. That's why it's a negative 2. I drew it, but I just didn't write it. All right, so back to this one. So here we go. It's negative 1, 1, 0, 0, 1, 1. So remember, this one looks like a little happy face, a little U shape. So this is the parent, y is equal to x squared. And now let's see what they want me to do with it. Now I see 3 numbers here. So we're going to handle one number at a time. So first of all, I see a 1/2. Well, remember, as soon as that 1/2 shows up, see, for that orange color up there, that 1/2 just means one thing. I'm going to do a vertical shrink by a half. So that means I'm going to go in here and multiply everybody by a half. So that's the first thing I'm going to do. So you know what? Let's take care of that now. So my new values would be, yes, negative 1, 0, 1 for the x's, but now my y's are 1/2, 0, and then a half. Okay, well, let's do that. Look, 0, 0, 1, and then I only go halfway up, and then I go up 1, and I go 1 over and halfway up. And so if you notice my happy parabola, notice how that smile, those little curves, actually got pushed down towards the x-axis. That's why it seems to get wider, because we're pushing it down. But this one right here would be y is equal to 1/2 x squared. So now we're dealing with these points here. Although if you notice, the 2, 1 would have worked also. Anyways, we have those 3 points as usual. So now the thing is, let's see what else they want me to do. Then they said, well, you know what? There's a +3, but it's on the inside of the parentheses. Well, when you have a number on the inside of a parentheses, that just means we're going in one specific direction, and we're going to think opposite. So we are going left 3. So it's a translation of left 3, but there is that one more number out here, that +2 on the outside. And so when you have that +2 on the outside, then that just means one thing: we are going up 4. So we're going to take care of all of this all together, the left 3 and up 4. Now I'm going to go with the easiest point, which is that 0, 0. So I'm going to go left 3, 1, 2, 3, and up 4, 1, 2, 3, 4. So left 3, again, why do I keep messing up my numbers here? It was up 2, that's all it was, just up 2. All right, so we go up 2 only. So left 3, 1, 2, 3, and up 2. There it is. So not this one way up here. All right, at least I caught it before I drew it. All right, so here we go. Now remember, when you're drawing the other 2 points, I understand they're a little bit tough because they're halfway up. But just remember, from our vertex, I go 1 to the side and halfway up. 1 to the side and halfway up. So I still have to do the same. 1 to the side and halfway up. 1 to the other side and halfway up. And just like that, there is our parabola. That's a little wider than usual. And this is the one that I can officially call g of x. All right. So you have the two U tries right below, but we're not done with the video yet. We're going to do 2 pages of we do's. Then we'll pause so that you can do the you do's after that. So let's flip the page. Let's try a couple more. Let's see how many we do's we have on this side. All right, so we have another we do right here. And it's another graph. Perfect. Let's see if I make a mistake on one of the numbers this time. Hopefully not. All right, first things first. There's my function, the y, there's the x, and notice it's between the absolute values. So clearly we can see that the parent function is the absolute value, which is y is equal to the absolute value of x. And again, I'm going to draw my little table. Doesn't take long to do. -1, +1, 0, 0, and 1, 1. Remember, it's an absolute value. Everybody's positive here on my y's. It's the same 3 points as a quadratic. The main difference, though, the quadratic curves. Remember, the absolute value, they're basically straight lines. It looks like a letter V when you draw it. So here is the parent function. Y is equal to the absolute value of x. All right, so there's our graph for the parent. Now, let's talk about all the moves they want me to make. So let's see, we have some room there at the bottom. We're going to write them there. The minus 3. The minus 3 is in front. Now, that means there's two things that are going to happen here. Not only am I going to do the negative means I'm going to do a reflection on the x-axis, but then there's also a 3. So in this case, that negative 3 is actually doing two things to the graph. And we're going to talk about how we can take care of that. It's doing two things. Number one, because of the negative, it's a reflection. So I'm going to reflect on the x-axis. So there's the first thing. But because there's a number 3, I'm also going to be doing a stretch. So there's actually two things coming out of that number. I'm going to do a vertical stretch by a factor of 3. And I know it says negative, but I'm multiplying by 3. So here's one way that you can actually take care of both of these at the same time. Remember, when you do a vertical stretch, you're going to multiply all the y values by 3. But since we're also going to do a reflection, then you can actually multiply everybody by negative 3. And by doing that, that takes care of the reflection and the stretching at the same time. So look at your new points. Notice how the x's still don't change. It's negative 1, 0, 1. And then this is negative 3, this is 0, and this is negative 3 there. So let's draw these points. Now, when we draw these points, we should see a reflection and a stretch. So let's see. Negative 1, negative 3. All right, look at that. There's the flip already with the stretch. 0, 0, and 1, negative 3. So again, by doing it like this, we took care of the reflection and, of course, the stretching at the same time. So there it is. There's the reflection and the stretch together. So now let's see what other numbers they threw at us. I see a negative 3, and I know I'm kind of low on space here. I can make it fit here. The negative 3 is on the inside. So because it's on the inside, the negative 3 is just telling me to go right 3. Because we do the opposite, right? We do the opposite of what it says here. So I'm going to go to the right 3 spaces. And it says minus 2. So if we're going with minus 2, then that just means one thing. That means, let's see, let's give it some color there. That negative 2 just means we're going to go down 2. All right. So I think we're ready here. X minus 3 and minus 2. So right 3, down 2. All right, here it is. Let's perform this operation. Right 3, 1, 2, 3, down 2. Right 3, 1, 2, 3, down 2. And then right 3, down 2. And there is our brand new function. And that's the one I can officially call g of x. Just like that. All right, so again, we're describing the transformation. That's what I wrote everywhere below. They tend to get a little bit messy, I understand, but take your time with it. Now, continuing with the we do's, if you look at the bottom, so there's your you do right there. But here's another we do. In fact, there's two we do's right next to each other, right after each other there. All right, so here are the we do's. It says, find the indicated nth root of a. What they're basically telling me is, remember, they're saying perform an nth root of whatever value they throw at you. So the 3 is out here. The a is on the inside. Now, this is, of course, where Desmos can help you out. We've talked about how to find these values on Desmos. The cube root of a negative, yes, it is possible. My answer is an automatic negative. And then the cube root of 216, according to Desmos, will be a negative 6. So these are very straightforward. The calculator will do most of the work for you, but you're learning and practicing how to set them up. Then, of course, we have this one here. It says, find the indicated nth root of a. All right, well, this is a fourth root. and we're going to put an 81 in here. And so again, let Desmos handle this work for you. The real thing that you're doing is just making sure that you're putting things in the right place, using Desmos appropriately, and then your answer is just a 3. Now, if you're concerned about, well, do I put a plus or minus? We're not solving for anything. So since we're not solving, we're just simplifying. We only get one answer here. All right, so you have 2 you-dos next to it here. So again, we're doing 2 pages of we do. So that's you right here. All right, so we have 2 more we do's on this page. So here's a we do that we'll do together. And I think number 14 is the last we do, and then we'll pause the video shortly, but let's keep going here first. Evaluate the expression without using a calculator. All right. I do see a power that's negative. That's what I like taking care of first. That negative power. Well, we don't like that. But a negative power just means that I'm going to change the position of the 25 in a fraction. Currently, that 25 is at the top of the fraction. So the negative means the 25 should belong at the bottom of a fraction. And I know it looks weird without anything on the top. So of course we have our 1 as a space holder. Now, it's still a fraction, and notice how it's now positive because I've already made the move. When you make the move, it becomes positive again. But now I see a fraction I see my power that's a fraction. So because I see a power that's a fraction, it means that I can transform this into a radical. And not just any radical, because there's a 2 in my denominator, there's my index of 2, which, by the way, I don't even have to write it. Remember, if there's nothing there, it's an automatic invisible 2. And then, of course, I'll have to put my 25 on the inside and the numerator. That power of 3 up at the top just ends up on this side. So now I can work this out. Look, 1 over the square root of 25 is actually just 5. But yeah, I have to give it a power of 3. And so 5 to the power of 3, don't forget, it's still at the bottom of a fraction, is 125. And just like that, there's my answer for this one. Again, evaluating. They want you to write it out, right? Get that radical going. If you see a negative, you have to put it at the bottom of a fraction, the usual. But then you have to simplify it because there's numbers. And then there's number 14. Find the real solutions of the equation. Round your answer to 2 decimal places when appropriate. All right, here we go. I am obviously solving for x. And if I'm solving for x, I notice that the x is actually stuck. It's stuck inside of a power of 3. Well then, I don't have a lot of space here. I'm just going to rewrite it really quick. Give it a little space there. Then the only thing in math that gets rid of a power of 3 is, yes, I'm going to need a radical, right? A root of some sort, but it can't just be any root. It can't be a square root. It needs to be a cube root. Remember, your index and your power have to match up. This is the only time that we actually divide powers. 3 divided by 3 ends up being just x plus 8. All right, but now I need a cube root of 525. So if I'm going to do a cube root of 525, again, this is where the calculator can come in handy. But unfortunately, it doesn't work out nicely. So for now, we are going to leave it alone. The cube root of 525 ends up being a decimal. Well, we're not ready yet. So again, no calculator yet. We usually wait. I'm not sure what happened to my letter Y there, but no calculator yet. We're just going to set it up. The only thing I have to do now, of course, is subtract the 8 from both sides. And again, if you're looking at this and going, yeah, but what am I going to get as an answer? Well, look, technically, this is the official answer. The cube root of 525 minus that 8. Now, you got to make sure that minus 8 is on the outside of that radical. So now that I have it like this, now it's time for the calculator. And when you type it into the calculator, I mean, you're typing it in exactly the way you see it here. So now we use a calculator. All right, now they said to 2 decimal places. So if you do this carefully with your calculator, let's see what we get on this one here, this version of it. All right, so the cube root of 525. Cube root 525. Get out of the radical, minus 8. So this is what the calculator tells me. My answer is 0.06714. They said round it to two places, so it's either 0.6 or 0.7. The number next to it tells me to roll it up to a 7. So your answer should be 0.07. And that's now our approximation. The one on top was actually our exact value. So remember, there's a difference between exact and then an approximation. All right, so we're going to pause the video for a moment. And what I need you to do right now is I basically just need you to work up to number 13. So we're going to give you some time. Do everything up to number 13. Please don't go beyond so that you can review with me as we go along. But right now you're working on numbers 1 through 13, which is basically anything left so far on these first two pages. So we're going to pause the video, get to work, and then we'll come back and do the rest. All right. Now that you've had a moment to work on numbers 1 through 13, and please double check your answers with the key that is available, then let's continue with the we do. So there was one more we do here for the solving. That's why I kind of needed you to hold up for a little bit. All right. So here is we do number 15. Now in this problem, yeah, I want to solve for x, and my goal is to get it all by itself. But if you notice, the x has a power of 6, but the 9 doesn't. The 9 does not have that power of 6, which is why I need to divide everybody by 9 first. So no taking the 6th root of anything yet. All right, so now I am left with x to the power of 6, of course. But again, I still need to do my division. 126 divided by 9, of course, is 14. So now I have this. So I divided by 9 on both sides. This is my new problem. Now it's time to bring in that radical. And it's not just any radical. Remember, it needs to match, the index needs to match the power itself. 6 divided by 6 becomes just 1. So there's my x. But remember, we are solving here. We are definitely solving for a variable. Because we're solving for a variable, and it's an even root, I should have two possible answers. And in this case, it's going to be the 6th root of 14, because it doesn't turn out to be a nice little number. But luckily, I'm not adding or subtracting anything else, so I am ready for the calculator. But technically, I do have two possible answers for this problem. And my two possible answers, once I type it into the calculator, is plus or minus 1.55. So again, that's why I kind of needed you to wait a little bit on this side, on the you-dos on this side, because you needed the reminder that when you're solving and you're taking an even root, you're supposed to end up with two possible answers for these problems, not just one. That's why if you look at number 16, that's an even root. And because it's an even root, you should already know letter A and letter C are out. You're supposed to get two possible answers for these. So just be ready for that. All right, let's continue with the we do's. We do have more we do's here at the bottom. So here we go. All right, use the properties of rational exponents to simplify the expression. That just means use your rules about powers and exponents. So when I look here, it says a base of 14. All right, I got a base 14 and a base 14. Okay, I can do some math here. And when I'm looking at it carefully, the 14 does have a power of 1. Well, I already know my rule. When it's division, I already know I have to subtract my powers. Now, this is what we mentioned in class the other day. We talked about when you have what happens when you have a power of 1. So remember, this means 14, and then it's 1 minus 1 over 5. But what we mentioned in class is you shouldn't write it as a 1. Remember, our elementary teachers taught us that we need to have common denominators for us to subtract. So if this one has a 5, then the number 1 should be called 5 over 5. Because that's what a 1 represents. 5 divided by 5 is 1. If this was a 7, then I would have called it 7 over 7. If this is a 10, I would have called it 10 over 10, because the number 1 can be turned into any fraction you want. So here we're left with 14 to the power of 4 over 5. So yes, we're left with a power that's a fraction. Now, it says use properties of rational exponents to simplify the expression. Even if I try to take it further and I do this, you cannot take the fifth root of 14. Nowhere up here does it say to write, to round it off. It doesn't say anywhere here to round it off. So no, you're not going to use a calculator for this. Since this thing doesn't work out and you end up with a decimal, you can either leave it like this, which is probably what they want on Big Ideas Math, or you can leave it like this one. But I think Big Ideas would want this one instead. All right, so when I look at number 19, now number 19, remember here I subtracted my powers, but only because the bases matched. The bases don't match here. If your bases don't match, then I can't subtract the 6 with the 6. That wouldn't make sense. But what I do notice is it's all surrounded with a parentheses with the power on the outside. Well, I know my rules there. The rule for that is everybody on the inside, the 10 to the 6, the 4 to the 6, everybody's going to get their own power of negative 1 over 6. Everybody gets that power on the inside. And I know there's a negative. We'll deal with that as it comes. So now, what am I supposed to do with my powers here? Well, this is the rule that says when you have one base with 2 powers, well, then you should multiply your powers. Right? That's the rule that we've been using since Algebra 1. Okay, well, look, I still have a 10 up there. I still have a 4 down here. Can't mess with them. I know they can be reduced, but not yet. We're still dealing with powers. So it says 6 times negative 1 over 6. Well, don't forget, there's a 1 under it, so then the 6's actually cancel, leaving me with just negative 1 for the 10. Well, same thing here. Technically, there's a 1 under it. So the 6's are actually going to go away, leaving me with a 4 to the negative 1. And no, I still can't mess with that 10 and the 4 because they still have power. So I can't simplify them. But here's what I can do. The 10 has a negative power. It was on the top of the fraction. A negative power means we'll change its location. If it's on the top, the 10 is now at the bottom with a power of positive 1. But you don't write positive powers of 1. The 4 at the bottom has a negative power as well. Well, if it's already at the bottom, then it needs to move up to the top. Remember, we don't call it flipping. Not necessarily, because they don't always all flip. In this case, they both did, right? They both moved. And now that it says 4 over 10, now we should reduce it. Remember, technically, I could divide everybody by 2, or you could let Desmos reduce it for you, and we end up with 2 over 5 as our result. Again, applying the rules. Just be very careful when applying the rules. Now, there's another we do, number 20. So let's go to that. Number 20, here we go. So here we have one with a lot of variables, and that's okay. It shouldn't be too difficult to do. I understand that everything inside is surrounded by a power of 2. That's all right, but you know what? We need to take care of the inside. We shouldn't have this many X's written down. We shouldn't have this many Y's written down either. So we're going to take care of the inside first. All right, so let's see. That power of 2, still patiently waiting. We're going to talk about everything individually. So the number 3 does not have a negative power. If you're saying, yeah, it has a negative 2, no. That's only the X. The 3 does not have a negative power. That means the 3 is going to stay. Down here at the bottom, the negative 2, no, that does not have a negative power. That negative is in front. That's not a power. The negative 3 here, that's only for the X. So the negative 2 will stay where it belongs. But now we have to look at the letters. So look at the X. It says X to the negative 2. That has a negative power. Well, then it can't stay on the top. It's moving to the bottom. The X to the negative 3 has a negative power. Well, it can't stay at the bottom. it has to move to the top. And remember, when you make the move, those negatives disappear. And then we have this y to the third. That is not a negative power. So I'm going to leave it up there. And then there's y to the 0. Well, anything to the power of 0 is a 1. And I don't need to write a 1 because there's so many other things already written here that we can basically, remember, a power of 0 is telling you, do not write the letter y. You're being told, do not write it down. Well, then we won't write it. We'll just cross it out. Now we're almost there. Still not ready for that power of 2, though. I'm just going to leave it out here, patiently waiting. Notice the only thing left for me to worry about here is, yeah, there's still a 3. There's a negative 2. The y to the 3 is all good to go. It's the x's. I should never see 2 x's written out. I know that I can combine them, and because it's a fraction, I'm supposed to subtract my powers. But where do I have more x's? 2 here, 3 here. I have more x's on the top. And what power would I have left? Well, 3 take away 2 is just a 1. Remember, it's invisible. I shouldn't even be writing it, but just want to remind you that that's what's there. See, the inside is now officially ready. I can now go on and give everybody, that means the 3, the x, the y to the 3, and yes, the negative 2, everybody is going to get that power of 2 that's on the outside. Yeah, I've been patiently waiting. Well, we're ready for it now. So here's my final answer. 3 squared, 3 times 3 is 9. X squared, okay, well, x squared can't really do anything there. But here's where I can do a little bit of math. You're supposed to multiply your powers here, okay? So this is going to be y to the power of 6. And then what's a negative 2 squared, which means negative 2 times negative 2, positive 4. So there's no negative left for me on that one. But just like that, there's our answer. So just be careful with your rules when it comes to powers as well. Now, there's a couple more we do's here, way at the bottom. So we're going to move down to number 24 after you simplified that. So look, a lot of simplifying, just like we did already. So you have examples on how to do all this stuff. Now for these, yes, this one is inside a radical. This one's inside a radical. And then they both say a 5th root. Well then, what we learned was we can actually work with both of these, but instead of seeing it as 2 separate radicals, we could just say that they're both going to be on the inside of the same one. So it's 1215 over 5. Now, once we rewrote it like this, well, then let's actually do the division. So we're going to end up with the 5th root of 1215 divided by 5 is actually 243. So now here's where we have to let Desmos help us out. It's a little bit tough without it. So we're going to see if Desmos can help me figure out what the 5th root of 243 is. And according to Desmos, just so you know, it is. There is a number, and it's the number 3. 3 to the power of 5 is 243. So it does work out nicely. All right, give you a moment to catch up with the writing there. So now we're ready, of course, for the last page of the we do. So flip it over. See how many we still have left. All right, we have another we do here. So it looks like we have 3 more we do's to go. All right. Now, once again, we see the situation where they both have the same root. And if they both have the same root, we said, then we are allowed to write both of these numbers on the inside instead. And then once I have them written on the inside, well, then it's time to actually multiply this thing out. And 4 times 162 is 648. Well, let's find out if there's a cube root for that. 648. All right, so let's see what the calculator tells us. The cube root of 648. And it's a big decimal. They didn't say anything about rounding. And if they don't say anything about rounding, then this is my official answer. Again, you can't just assume, oh, I just have to throw a decimal for it. Nah, they don't mention rounding. then you shouldn't be doing it. You just leave it like that. Okay, moving right along, number 28, another we do here. Now, one of the issues that we had with number 28 was this radical. Remember, we do not like to have radicals in our denominator. And in order to get rid of this radical in the denominator, normally we would say multiply the top and the bottom by radical 6. But unfortunately, this radical is connected with a 9, with a little bit of subtraction there. So then the only way to get rid of these is to multiply by what we call the conjugate. But whatever you do to the bottom, you have to do to the top. And remember, the conjugate is this. I see a 9 in the front. Well, then they both say 9 right here in the front. There's a radical 6 towards the back, then a radical 6 towards the back. What is it that officially makes it a conjugate? Remember, this one says minus. Then I have to do the opposite sign, and that's where the plus sign kicks in. So we're ready for it now. I can easily perform the conjugate on the top. I'm going to multiply twice. So here we go. Let's see. 8 times 9 is 72. Plus sign. And then 8 times radical 6. Remember, you can't actually multiply an outside number with an inside number. So then I end up with 8 radical 6. Now at the bottom, remember, this is where we officially multiply 4 times. So the first one, 9 times 9, 81. And then again, the 9 with the radical 6. Well, then that's 9 radical 6, and it's positive. But we also have to multiply everybody by a negative radical 6. So negative radical 6 times 9 is negative 9 radical 6. And of course, negative radical 6 times positive radical 6 is a negative. Now remember what we said. Radical 6 times radical 6 is just 6. That was the whole point of what we learned with trigonometry as well. So we're bringing that rule back in. All right, and now looking at it carefully, we have, for this problem, the 9 radical 6 and the 9 radical 6 cancel each other out. So on the top, we have 72 plus 8 radical 6 all over. And then 81 minus 6 is just 75. And just like that, there's our answer where we have officially rationalized the denominator. I no longer see a radical in my denominator, and that was the goal the whole time. And so that brings us to section 6.4. Now notice, we started this review with graphing. Remember, 6.4 was basically us just graphing again. In this one, they said, hey, here's the parent. So they're giving me the parent function. So the parent function is there for us. Well, I already know what the points for the parent function are. For the parent, let's see, we have some room on this side instead. So for the parent, there's the x, there's the y. Now remember, this one is the only one that doesn't use -1 because my graph doesn't exist according to our domain. So then it's 0, 0, 1, 1, and then our guiding point was the point 4, 2. So that's what we learned last week. So here's 0, 0, 1, 1, 4, 2. Here is the parent function called f of x. So now we're going to talk about every move they want me to make. I do not have a number in front of the radical, so there is no stretching, no shrinking. There's no negative in front, so there's no reflection either. So they're being kind of nice to us on this one. All they said was -3 on the inside. So don't forget, if it's a -3 on the inside, well, then that just means I'm going to go to the right 3 spaces. And of course, I also see a +4 on the outside, but a +4 on the outside would mean that I'm going to move up 4 spaces. All right, so we're actually ready to draw this thing already. I'm going to move everybody right 3 and up 4. So my starting point was 0, 0. Well, I'm moving it to the right 3 and up 4. My next point was here, 1, 1. So I'm going right 3, 1, 2, 3, and up 4. 1, 2, 3, 4. Now, if you notice, I'm not really going to have the graph to move this point, but that's fine. That's just, we use it as a guiding point anyway. So we know this graph is going to take off and it's going to go up forever and ever. So there's my graph, and that's the one that I would call g of x. But remember, one of the things that we're going to be tested on is the concept of domain and range. So we want to make sure we talk about that, even though it's not in the directions. We should bring that in. And so remember, when we're doing domain and range, I look at this starting point. We called it the starting point because there's no graph anywhere else around it after that. And that's the point 3, 4. So my starting point, I'm just going to write the start point is 3, 4. Remember, that's what's going to help me for my domain and my range. So when I talk about domain first, so let's mention domain here. And we have room towards the bottom. Yeah, we have plenty of room here. All right, so domain. We've already mentioned that domain deals with x's. So I write an x. The x value in this starting point is the 3. Well, then I know the domain has to do with the number 3. We know the point actually exists there. So I put an equal sign. Remember, when you're doing domain, this is when you ask yourself, is it to the left or to the right? That's the question. So when I look at this graph, and I can bring in my little card as usual, or just anything to block it out. So when I'm looking at my graph, here's my starting point. So the question is my graph to the left, to the right? Or is my graph existing on the left side of that point? Well, clearly there's nothing on the left. This is only to the right, which is why my domain is greater than 3. Because again, I ended up going to the right side. So that's why it was greater. Then when I'm doing my range, well, let's talk range here now. We know that range deals with the letter y. And when I look at my picture, my starting point, that means the number 4 is involved. Yes, there's a point there. Then I need an equal sign. But when you're doing range, the question is above or below. So I'm going to go to my starting point again. My starting point is right here. So the question is, if I put it right on that point, does my graph exist below this point? Or does my graph exist above the point? Well, clearly the graph is above. And because the graph is above, numbers only get bigger when you go up. So my y is greater than or equal to 4 because we went above. And those are the type of questions we ask ourselves when we're doing domain and range, specifically for this type of graph, which is what they're going to ask for on the test. All right, with that said, it's now your job to finish the rest of this packet for the you-dos. Please double check your answers with the key. And then once you're done, you're going to drop it off for me in the basket. All right. And if you do finish early, please jump on to BIM and work on that and try to get that done too, because we have a test next week that we need to get ready for. All right. Have a wonderful day, everybody.